So are you saying inbound was showing a fault?
Let me get done with Pezzi so I can restart talking again.
I'm good.
Okay. So what the fault indicator does, sitting on the conductor, I'll just draw a little window for one. It's got the F in it. What a fault indicator does is it measures the intensity of magnetic field. The only thing that's really inside a fault indicator is a magnet. And it measures magnetic field. And if the magnetic field, because of load, high intensity load on the conductor gets too high, it makes that little window trip. So that's how it trips. So every fault indicator that sees fault current is going to trip. So fault current, if the fault happened here, will these indicators, and usually you don't put them on both sides, you put them on the A side. Did these indicators see a fault?
Yeah.
Okay, did these indicators see a fault?
Yeah.
Yeah, okay, and of course the fuse is blue. That's our other fault indicator right there. So all of those saw a fault. Did the indicators and the A of this transformer, did they see a fault?
No.
No, because it's beyond the fault occurrence. So all of these tripped, and the fuse is opened right here. Thus, the fault is in between the B side of this transformer and the A side of this transformer. That making sense to everybody? Tell me now, because this is important. All right, little quiz here, stand by. Not graded. That designates normal open point. Transformer 1, 2, 3, 4. Fuse. Blown. Red. Red. White. Where's the bad span?
Between 2 and 3,
Okay.
B to A, right?
Right. From the B side of here to the A side of here. Somewhere in that span, I've got a fault. I am not locating the fault location. I'm locating the faulted span. Okay? That's the fault indicator method. And nowadays, Robbie can attest to this too. Nowadays, you just go to these transformers, and the transformers have a little window on the outside of the transformer, and you can actually see the flag just by driving by it or walking by it. Most of you don't even need to open up anymore. Those little digital LED ones are great at night. You just drive by them and see whatever's flashing, and you go between a flashing one and a non-flash. Where's the fault at? Between 2 and 3. Flashing, non-flashing. This one will be flashing also. All right, sound good? One method of determining faulted span. Okay, method number 2. This one's going to get a little bit more difficult. Remember this video, Robbie?
Oh, yeah.
Okay.
Oh.
Well, there's almost no difference on those. That went together nice. Okay, you ready? Let's get down.
Let's get down.
Yeah.
Purpose of this segment of the video is to high pot underground cable.
Okay, so what did he call it?
High pot.
High potting.
High pot. All right, you need to write that down in your notes. High potting underground cable. High potting is short for putting something, whatever you're testing, to a high potential. High potting equals high potential.
So we can determine the integrity of that cable and how to meter react to conditions of cable. Kirk, you've got your meter already set up on your hot stick, and I've got the non-metered end set up, and of course it's.
Okay, so what you're looking at here, do you remember the previous safety video that you saw with Crepesi? I guess you do. All right, he's using the same meter and the same sticks. These are two phasing sticks that he's using right here. And the one that he's got, the guy, the right-hand guy, he's got the digital meter side. And you'll notice in that hand, that white section, that's what they call the high pot adapter. So now we're not testing anymore for presence of voltage. We're actually introducing a voltage onto the conductor with that white piece section. All it is a huge resistor. And we're introducing a DC voltage with what they call a high pot adapter. That's what he has in his hand. So a good question would be, what additional piece to the phasing sticks is required for high potting underground cable? What will it be?
A high pot adapter.
High pot adapter. There you go.
It's important that we put the DC high pot adapter on the metered end. We've selected the right length sticks for safe work procedure for this utility that we're at. And regardless of the length of the sticks that's required, the voltage that you're using, the extra acceptance of the stick is for a more accurate reading of the high pot adapter. Allow me to get these sticks out of the way, and we'll get that cabinet opened up, simulate some of this high potting.
John, I went down to the next cabinet and I isolated all three cables that were.
Okay, so just to give you guys a heads up, this is really just a test in a video to show you how the sticks work and the high pot adapters work. You typically won't see this situation inside a cabinet, and I know it's dark inside, but they're doing this just for test purposes. And I'll stop the video at points where they're using the sticks and what you need to do. So that's just a disclaimer right there.
We're going to check.
Okay, so what does he mean when he's talking there? What does he mean by isolating the cable on the far end?
Open the circuit.
Yeah, in what manner?
Just disconnect it from the transformer.
Yeah, so if I'm coming out of the transformer 1 and it comes out on the B side and it goes into transformer 2 on the A side, what do I need to do with the transformer 2A wire?
Disconnect it.
Disconnect it, and you can put it on a standoff. We saw those standoffs yesterday. Disconnect it and put it on a standoff. That's a dead end. And stop. You definitely cannot leave it on the transformer, because if you do, it's just going to test cable on and on and on. And this stick does not work through transformers. So you can't use this testing the actual transformer core itself. It's going to give you a bad reading.
We've got three cables that show a variety of faults on them. And so we're going to show what happens with each of the different conditions. I think that's tight enough. This is
Okay, so with the situation, what he's got going on here for the test purposes is he's got one energized primary coming in, and these three cables that he has right here on here have three different types of fault conditions on them. And we're going to need to take notes on those to find out what kind of fault they have on them. So I just want to give you a heads up on that.
This is an 8300 volt underground system that we have, 4800 volts line to ground. We've already installed the feed through. This is our feed in. This is a dummy cap. This is where the feed's going to come from. There's three different faulted conditions, and we're going to illustrate each of the 3 faulted conditions. Ready, Kirk? Let's take that dummy cap off. And pick one of the 3 cables and we'll put in that feed through. Here, not square. Okay, so if you'll go into that.
So you'll notice here, and he needs to do this situation in the cabinet. In order for the sticks to high pot, you got to have one energized source free to put the stick on, and you got to have one source on the other side, or one input on the other side where you can put the other stick on to test the conductor. Voltage is required to have to do the testing with, so that's where he's gathering it from right here.
That hot bushing, Kirk, and I'll go to line to ground. We're going to read the line to ground voltage.
All right, what's he got on the sticks there? Anybody read?
200.
Yeah, 3.2. Now, this is what happens when you're converting AC to DC. What did he say his line voltage regularly was? 4,800. His line voltage, as far as AC is concerned, was actually 4,800 volts. But due to the conversion to DC with the high pot adapter, we're only going to get 3,200, which is about, what, 60% of what the conductor is. So a 3.2 reading is okay. He has gone from the primary conductor to ground with the other stick to measure a voltage.
And that voltage is 3.2?
The reading we expect to get will be between 60 and 70% of the line to ground voltage. And that's what we're seeing here on the meter.
I'll put my non-metered end into the bushing for the cable that we want to test, so that when you plug into that energized bushing, we'll be able to watch the meter. What often happens is on a short run of very good cable, the meter reading is very short duration. So by watching it, you see the actual reading. I'm seeing 3.2. That's a bolted fault.
Okay, so the first cable he tested right here is reading a 3.2. What did he call it?
Bolted fault.
Bolted fault. Now remember when he tested the sticks and he went directly from phase to ground, he went from the energized side to ground, his reading was 3.2, right?
Yeah.
Yeah.
His reading was 3.2. All right, he's doing the same thing exactly here, except now it's on the conductor. That's why he's called it a bolted fault. The center of the primary conductor is making physical contact with ground, and he's unable to charge the cable. He's always introducing 3,200 volts DC onto the conductor. This is not going down, so this is what they consider a bolted fault. The question on the test is going to be, I put my phasing sticks to test my conductor, and the voltage always stays high. What kind of fault is on the conductor? Bolted fault.
That's as short as it gets. It's a bolted fault. So we've got a bad underground situation here. Okay, Kirk, we've tested that first cable and found it to be fully faulted. Let's take another cable of your choice and put in that feed through, and we'll check the condition of that cable. Hopefully we'll have a good cable. We can get some of these consumers back on. You got the metered end. I have the non-metered end. I'll plug into that feed through. And when you're ready, boy, I had good current flow to begin with. It's reducing. It's charging the cable. the cable's accepting that charge. I went from a full reading to a 0.1. That and to 0. That is a good underground cable.
Okay, I know it's hard to see on the meter. I can hardly see it, and I'm here at the house with mine on the laptop. He said he put the sticks on. It started high and went completely down to 0. What kind of conductor do you have there? What condition is it in?
Good.
Good cable. And what is happening there is you're actually just charging the cable up to 3,200 volts. And once it's fully charged, it has nowhere else to go. It's insulated. So we know we have a good cable there. Thus, the meter is going to read 0. Starts high, goes to 0, is good conductor.
No fault. Very good cable. It's held the capacitive charge. Let's reverse our sticks and take that capacitive charge off that cable.
It's real important to make sure that you're watching the meter when you plug it in, though.
It truly is.
To
Truly
see
is.
that initial reading and then watch it bleed to 0. If you're not
Exactly.
watching it, you wouldn't be able to pick that up.
You would know if you had any current flow. Okay, well, bleed that. I'll trade you sticks. And go to ground. And it's very
Okay. You need to do this. Now, they tested the first cable. They didn't do this. My company made it mandatory that every time you tested a cable, regardless of the condition of the cable, you always grounded the cable and your sticks. That's what they're doing here. They just reversed the sticks to the feed, and they're taking the cable itself and they're going to ground with the other stick. Now, you notice they're not testing anymore, and they're touching the sticks to ground. How much voltage is on the cable?
300.
300 volts. That's how much of a charge that still remained on that cable before they grounded it. Ground your sticks every time after you high pot cable, and ground the cable.
a short duration went to 0.
John, it's very important that when we discharge the cable, that the discharge time needs to be equally as long as the charging time. And even though the meter reads 0, it still may have a charge on it.
Okay, Kirk, let me go into the non-metered end, into the cable to be tested, if you'll energize that DC high pot. Now we got a good initial current flow. It's accepting the charge. It's dropping to a low value. It's obviously a punctured cable. It's dropping back off again.
Okay, see what happened right there? Started high, went down, and went back to high. Okay, I'm going to re-show that one again.
Thank God that a punctured cable, right?
End into the cable to be tested, if you'll energize that DC high pot. Now we got a good initial current flow. It's accepting the charge. It's dropping to a low value. It's obviously a punctured cable. It's dropping back off again.
Okay, yes, it's a punctured cable. So there's no real direct contact between the center of the conductor of the primary and ground. You need to charge that cable up for a little bit until it eventually flashes over to ground, because there's a puncture in the conductor. So it's making its way through the insulation to the outside ground. That's what they call a puncture cable. Starts high, goes down, goes back to high, punctured cable. That is a bad cable.
It's fluctuating, accepting the charge and then discharging it. So we have 3 situations. We have a good cable, a fully faulted cable, and now a punctured cable. And the only other one that happens extremely rarely is where we have a burnt open and real dry conditions or in sand, and it accepts the DC charge, but you have a cable that's burnt open. And you have a faulted cable and it's showing it as good. What you might want to do is go to the next cabinet and put your URD grounds on that cable that you're testing, and then come over and high pot it again. If you don't see the line to ground, full current flow, it's in fact opened. So you have an open cable. and that's the exception.
Okay. Any questions there on how you use or what readings you will get with a Hastings high pod adapter on phasing sticks? Okay, gentlemen, let's take about 10, take a break, and we'll be back shortly.
One more time. Methods for fault to span are
Fault indicators and DC high pod. Just to let you guys know, I am videoing everything here, so it will be posted up and you can go through this again. But questions are definitely welcome, or repeats, no problem whatsoever. Okay, so who was that? I think it was Willison was asking, well, what do you do after you have determined that the span is faulted? There are two methods of installation into the ground of underground, both primary and secondary cable. One is the direct burial method, and the direct burial method is just the way it sounds. You're going to put the conductor, whatever it is, secondary or primary, directly into the dirt, bury it right in the ground, which is okay. The cable is meant and insulated and protected enough to be able to do that. That's the old-timey method, or in some cases, just a temporary, if you're doing something that's going to be temporary, not lasting for a long period of time, a short period of time. The new method nowadays is cable and conduit. So you're going to install cable into the ground, then install cable into the conduit. So the more modern way, and you will run into two different types of situations, and you'll see it out there when we look out there at the field. We started putting cable and conduit, oh gee, Robbie, what? 20, 25 some odd years ago. And the thought processes were, well, if you're running either 2 or 3 phases, just put them all in one pipe at one time. Just get a big size pipe. What we soon realized and figured out there is that if you had one cable fault and you had 3 cables in one pipe, what did you need to do?
Like some more.
You had to replace all 3, which was not, underground cable is expensive, which was really not cost effective. So the more frequent nowadays is what you'll see a cable in each individual conduit. So instead of using one 6-inch conduit for 3 primary cables, you're going to use 3 2-inch conduits for 3 primary cables. That way, if you have one faulted cable, you're able to pull that one in and out and not have to worry about the other 2. It's going to save you a good bit of money. Okay, so the 2 different methods: direct burial, that's putting the conductor directly into the ground, and cable and conduit. Now, as far as repair is concerned, obviously, if you find the faulted span and it's cable and conduit, what do?
Just pull a new cable through with the old one.
You got it. Yeah. They're usually not burning too. Like that guy said in the other video, you're usually not going to find a cable that's burned completely into. Connect your new cable to the old cable that was faulted. Pull out the old, and it pulls in the new at the same time. Re-terminate it, and you're good to go. Now, we will talk about, and we'll go to it right now because I've got the video already queued up here, as far as finding and locating an underground fault for direct burial. So here we go. My good old speedy computer. All right, the piece of equipment we're going to use here is what's called a Vaughan thumper. Vaughan is the name of the company, and a thumper is exactly what it means to say. It charges the cable up. It charges up the cable to a certain point, and then injects real high voltage on it, and the cable thumps in the ground where the fault is at. So here's how it operates.
The Von Arc reflection system is an easy-to-use, easily transportable cable fault location device. It allows trained users to quickly isolate faulted primary underground cable. This video will highlight some basic operation features of the Von. If you have operation questions once you're on a job site, please contact your Von representative. In the West region, contact James Landers at 352-408-9630. In the East region, Canada, and international inquiries, contact Jerry Landers at 352-408-7890. If you can't reach a representative, a number for the Von Corporation and brief operational instructions are listed on the inside lid of your system. One very important note. The Von Corporation recommends that operators use all of the safety measures demonstrated in this video. However, nothing supersedes the safety regulations of your company. If there is a conflict, always follow the safety rules and regulations of your company. The Von Arc reflection system combines a user-friendly cable radar with a capacitive discharge unit in a compact, lightweight, portable package.
Okay, so there's two. Levon's here. How about that? Hold on one second. Is he in the room?
Yo, Levon.
Was that English? Levon.
Yo,
Good morning, sunshine.
good morning.
Okay, so the Von Arc reflection system, as far as its operation right here, this is a really sophisticated piece of equipment, but surprisingly very easy to use. They are grossly expensive. We had one for each service center in Santee Cooper, and there was 4 service centers. They cost right around $32,000 a piece. But as far as their operation is concerned, for direct buried underground primary cable, they're priceless. There are 2 modes to the Von Arc reflection system. One's a radar mode that doesn't introduce voltage, that introduces a signal. And then there's thump mode. That introduces voltage, so you're able to find the problem underground. Can anybody see the screen that's up at the top there and make out what's going on?
It's a heart monitor.
It's
Measuring the, it's looking at the voltage or the current.
No, there's no voltage and current on this cable yet. It's charged, but it's not doing anything yet. Okay. It's sending a radar signal down the cable right here, and it shows there's some hash marks. There's one here and one here, one here and one here. It is showing the actual span of primary that you're testing. And down here at the bottom, I can hardly see it, it's going to show you the actual footage right there here. Now, on the top, there's a peak that's right here, and there's a valley right here. You're able to move these hash marks back and forth. Remember, we're just doing this in radar mode. We're not putting any voltage onto the cable yet, and get a general distance between your start point and where you think the fault is at, where the machine is doing this at. Excuse me, where the machine thinks the fault is at via radar, not thump. All right, do consider this now. The wire's got to leave the transformer, go down, go the full distance. No ditch is exactly level all the way through. Underground primary cable might make turns. The longest span of underground primary cable I've pulled point to point is right around 3,200 feet. So this can get long. Radar mode gives you the general location in feet where you need to go. Once you've got it on radar, you can just take out a measuring wheel or whatever you need to do and just walk down the suspected path of the underground primary cable.
Finds a user-friendly cable radar with a capacitive discharge unit in a compact, lightweight, portable package that's easily transported in virtually every truck, van, or SUV. Let's see how easy it is to use the Von system to locate a fault on an isolated cable section.
All right, once again, when testing, what do we need to do with the cable? On the far end.
Unhook it and ground it.
Unhook it,
Hold on.
unground it. We need to
I gotta isolate. There it is. I had it in my notes. I was looking for it.
well, it's on the screen too. Okay, had to isolate, which is dead end or put on a standoff bushing, the far end of the cable before we test it. Again, this will not test through transformers and pretty much will damage a transformer if you put DC voltage into it.
But before we begin, here's 2 safety notes. If possible, all hookups should be performed using a hot stick and or properly rated rubber gloves, depending on your utilities requirements. We'll illustrate the hookup on a typical dead front pad mount transformer. Before you begin, remember the far end of the cable being tested must be parked and or open, not grounded. Begin by cleaning enough of the neutral bundle so 2 connections can be made. The green safety case ground Vaughn provides and the approved grounding jumper device that your company uses. Cleaning the connections is the most important step of the hookup process. Notice the lineman cleans the grounds and the concentric neutral of the cable under test. Vaughn recommends using a feed-through device so the parking bushing is removed and the feed-through installed. Make sure the cable that's not being tested has a bushing cap or cover to avoid inserting the high voltage lead into the wrong bushing. You can see here how close the feed-through is to the transformer bushing. That's why it's critical that any open bushing be covered with an approved bushing cover as illustrated here. Using a hot stick, the elbow is inserted into the feed-through and a grounding elbow is installed into the open bushing.
Okay, so we're at the point right now. This is direct buried cable. The previous video, the guy's high-potted this span of conductor right here and found a fault on it. Right? For safety reasons, he's going to re-ground it again. And the next steps will be, now I need to locate the fault. This is the bad primary span. I know that. Now I've got to find out where it's bad at.
Some utilities test from the parking bushing by removing the access port cap. Then, using an approved voltage meter or detection device, test the other side of the feed-through or test port to ensure the cable is de-energized. After you complete the testing, be sure to insert a grounding elbow in the feed-through. You're now ready to hook up the leads from the Vaughn. One quick note, be sure the green safety case ground is uncoiled fully before beginning the hookup.
Okay, did you hear that safety note? That'll be a test question right there. The green, and that's the case ground to the Vaughn, has to be uncoiled completely, even if you have to stretch it out over the ground. Why is that?
Will act like as a winding.
It will. That's right. If for some reason you have a fault on the conductor, or you have a situation where just something goes wrong on the conductor, that coil on the ground will intensify and make the voltage go even higher. So you have to uncoil the ground lead, and it's coiled up on the machine here. He uncoils it and just stretch it down the ground to a straight line before connecting it.
Are these usually on a truck? Mom?
It's inside the actual piece of equipment here. Everything's.
What I'm saying is that something that's typical on a lawn truck though, or is that something special if you're troubleshooting?
This is special if you're troubleshooting. We actually have a trailer at our service center, enclosed trailer, that has the sticks, the high pot adapters, and this Vaughn piece of equipment, and a generator inside of it, just in case you need to charge it. That all rides around in a trailer.
Go for it.
Or detection device. Test the other side of the feed-through or test port to ensure the cable is de-energized. After you complete the testing, be sure to insert a grounding elbow in the feed-through. You're now ready to hook up the leads from the Vaughn. One quick note, be sure the green safety case ground is uncoiled fully before beginning the hookup. Begin by attaching the green safety case ground. Then, connect the high voltage return to the concentric neutral on the cable being tested as close as possible to the cable termination.
Okay, so there's a couple features going on here. That's a safety ground he put on, but you also need a neutral return path to the machine also. So really there's two grounds on this machine. One's the safety part of it, and the other one's the neutral return path.
Point. Next, remove the grounded elbow. And finally, insert the brass elbow probe attached to the high voltage lead into the bushing.
Okay, this is the high voltage one where I'm going to inject a high voltage thump onto the conductor. So it's going in here through the feed through, and it's going to be going out this conductor right here. He doesn't say much about it, guys, but once he takes this stick off, if you're walking around this area or standing around this area, this is brass, and it is an open live conductor. Now, depending on your machine, this can get up to 34,500 volts. So this is an area to stay clear of while you're testing.
We're now ready to find the fault. The operation of the Von Arc reflective system, regardless of your model type, is essentially the same. Brief step-by-step hookup and operating instructions are located on the inside lid of the Von reflective system for easy reference, including the phone number for the Von Corporation. To begin, set the voltage indicator with the white mark up, then switch to the lowest voltage. Check the battery to make sure it's fully charged, place the machine in radar mode, and turn the unit on. The Von will then automatically find and mark the open.
Okay, so that's, you're actually in radar mode right off the start. Now, how much voltage am I putting on the cable?
None.
Zero, none. You're in radar mode right now, okay? And we'll talk about something here in just a moment.
Next, push the green start button. The unit will charge to the level you've set on the indicator. It will then discharge, and the fault will automatically be marked.
Okay, so now he has introduced voltage onto the cable. All right, it's thumped one time, and you'll notice on the screen right here, this was the full span, here to here, and you can move these hash marks to get a measurement. All right, now the thumped one gives a picture for it right here at the bottom, and you'll actually see this inversion right here. You see it? All right.
Yep.
You move this cursor over to here with these arrow markers. You move it right over to the leading edge of it, and that's going to tell you a footage on the bottom to the fault.
Marked. The distance to the fault from your test point is located in the lower left position of the screen. In this case, the fault is 394 feet from the test point. Now a second worker can travel the cable path the approximate distance indicated by the Von trace. The unit operator then presses the stop button and switches from radar to thump.
Okay, now you go into thump mode. Now it's going to inject, what it's going to do is going to charge up inside a capacitor inside the machine. And when the machine charges up, it's going to send a very high voltage DC current down the conductor.
And presses the start button. The unit will then begin an auto thump sequence every 11 to 14 seconds.
Okay, I'm going to rewind it back and probably do this multiple times right here. And I'm going to turn the volume up, so be careful. You can actually hear the thump in the ground.
To 14 seconds.
Did y'all hear it?
Yeah, it sounded like somebody knocking on wood.
That's it. It's exactly. And to be honest with you guys, you're actually going to be able to feel it more than you're going to be able to hear it. You're going to be able to feel it in your feet. Your feet are going to thump a little bit. You get these and they're really deep. The favorite of linemen to use out there, and they're hard to find the sound or the thump, is grab you a traffic cone and put a traffic cone on the ground and put your ear to it, and that'll intensify that thump sound. So he has got a general by radar with the wheel, and the thump every 11 seconds is going to pinpoint exactly in the dirt where the fault has occurred. All we're doing here is injecting a very high DC voltage, and it's making an explosion in the ground where we have the fault at. Okay, so it goes on to other features of the Von Thumper, which are pretty in-depth. You really don't need to need those right now. What we did on our machine is most of our faults were on a certain size cable. So we just set it that way and left it that way as far as that was concerned. The rest of the video just goes into more technical features. All right, so once you've located it like that with the Von Thumper, dig it up, splice it, and you're good to go. Okay, so any questions there? Good. What time we holding?
I actually got one, Chief.
Sure.
So you're sending DC current through the line to find out where the fault is, right?
Correct.
So do you need to ground that cable again before you start working on it?
That's a good general practice. Now the fault itself, the machine does it itself.
Okay.
Once you hit the stop, you mean that red stop button right there? Oh, I do need to go back on that.
So it de-energizes it.
Yeah, it's built in the machine. Let me get reshare this back here for you. Okay, you seeing it back again?
Yes, sir.
Okay. Once you hit the stop button, that is a feature of the piece of equipment right here, is that it grounds itself inside the machine to that green wire that goes to the ground outside. But it is always a good idea to go ahead and reground it like you saw him do before, physically in front of you. The other part of this is here, and do you remember when the lid was open and it showed all the red and green writing in it?
Yes, sir.
Do the green stuff, you're good to go. Do the red stuff, you're going to break something. All right. What most of this, most of the errors come into this right here is you're going to have to put a voltage on the cable. Let me see if I can get a clean screen on this right here. There you go. If I'm working with 7,200 volts on my normal operating system, how many volts? And it's a 15 kV cable, so it will go to 15,000 volts. Sometimes you're going to have to pump that voltage up a little bit, especially if you're in dry sand conditions, but you never really want to go over 10,000 volts. So if you got a 15,000 volt cable, 10,000 volts is plenty. If you got a 34.5 kV cable, I wouldn't go over 20,000 volts on it. All right, if it hasn't faulted out by that time, you may still have a good cable. What you cannot do, and this is what this little red sign right here says, it's got it in the lid, and here is start the machine and adjust your voltage. That is a no-no. So if I came up here and started and my cable was a 15 kV cable and it only came up to 4,000 volts, can I turn the knob to adjust it?
No, because you're adding even more current, right?
No, well, what it does is it messes up the capacitor inside. You have to stop the machine, readjust up, start again. If it's still not high enough to what you're desiring, stop, adjust, start. That's the same way up and down. Do not adjust this while this red light is on. It will destroy the machine. Any other questions there?
Yeah, so is this only for volted faults, or can you use that for puncture cable too?
Okay, you can use this for puncture cable, and there is actually a solution here to be able to find out if I've got an open cable. And I know it's rare, but you guys will be aficionados on this as soon as you figure this, get this little bit of tidbit of information. So, am I still in share mode? Yeah, good. Okay. He had a real nice screen up just a second ago. There it is. Hold on a second. There it is. Okay. So when we started out, what mode were we in? Radar or thumb?
Radar.
Radar. Okay. What's going to happen here? on a fault indicator, if you fault it out and the fuse is blown, you've had a fault one time. But on an open, either in the pipe or in the ground, what do I mean by open when I say open?
Like a broken cable.
Yeah, and I'll try to draw this out for you. Do you guys see the paint screen that's up?
No, sir.
Okay, hold on. Let me share the whole screen.
Yep.
Okay. Okay, I'm going to just draw a primary conductor here. The center core of it. This is the actual where the voltage goes. And this is the insulation. You got ground on the outside. We'll go more about that later. What happens here on an open of a primary conductor is it burns in two. And the center conductor is here. But it burns so well that I still have insulation here and here outside the cable. So when I introduce a DC high pot adapter or DC voltage on this inner core, it doesn't have enough voltage to get over here to ground because of this insulation is still in it. That's an open. Make sense? The conductor's burnt completely in two. Oops, Control Z. Here's the other side of it. It's going down here. Core in the middle. All right. I'm introducing my Von Thumper voltage on here, but that voltage is still not high enough to make it all the way across this insulation to ground to be able to produce a thump. That's an open conductor. All right, let me get back to the video. There is a way with the Von test equipment to be able to determine if I have an open conductor. You'll see on the screen here that I've got the beginning of the conductor here, my assumed end of the conductor here, and after I've thumped it or radared it, it's going to give me a general, well, I guess the fault is right here. What you can do in this situation is if you need to confirm that you're at the actual full length of the conductor, is go to the far end and have a guy standing there with a grounding elbow and ground it. Let me get back to my paint screen. This is in radar mode, not thump mode. So let me start a new. New. Don't save. Okay. So I'm going to draw the screen out as you're seeing it up there. Okay. Machine is telling you, and it's going to draw a line. This is the beginning of your conductor. That's the end of your conductor, and you've got this little hump right here that designates the end. It's going to show you footage. 504 feet. How can I confirm that this is the actual end and not the open? Any guesses?
Wheel it off.
Huh?
Wheel it off.
That's a good one. What if the fault's, what if the open's right here and it's real close? Radar mode is good, but what happens here in radar mode, and you can't tell this, here's where I'm testing from. I don't know how deep it goes. That's footage. I don't know how much my ditch undulates. So that's extra footage. I don't know if it makes a turn and goes around here. So radar mode is the general, get me kind of close. So how? How can I confirm in radar mode that this is the end? Is everybody?
Ground the cable and see if the footage changes.
Well, you got. I like the way you're headed. What happened when the fault occurred inside here? What happened to the picture? It did that number, right?
It became inverted.
Became inverted. There. What can I do? I think I hear you. What can I do to the far end to make it inverted?
Run it, make it pulse it again, or what's the term you used? Charge it to see where the fault's at.
We're in radar mode. We're not charging it.
Oh,
What did I write on the screen?
ground it.
Ground it. There you go. If I have my machine and I tell the guy by radio, hey man, ground the far end, I'm going to draw this end of the line right here. It's typically like this. What is that thing going to do? It's going to invert. All right, man, take the ground back off. What's it going to do? All right, man, put the ground back on. It's just going to go back and forth. When you go on and off, you know now that you have the full span of cable. All right, you send them down there. Hey, man, put your ground on. Nothing happens. What's wrong in the dirt? You have a what?
Open cable.
You've got an open cable. Okay, those are very difficult to find. All right, so good question here. How do you determine the far end of the cable with the Von Thumper in radar mode?
Ground it.
Ground it. There you go. Ground it and watch for the inverted signal on the screen. Okay. I mean, what you're really doing right here is you're creating your own fault in radar mode, not in thump mode. Okay, which doesn't hurt the machine. That's what it's meant. Okay. All right. Any other questions there as far as the Von Thumper is concerned? Good deal. What time we got here? 10:30. Robbie,
Yep.
you gonna need to go here in a minute?
Yes.
Okay. I've got one more video, gentlemen. Thus far today, we have talked about what voltage of cables, primary or secondary.
Primary.
Yep.
Primary.
Talk about primary all morning here. Okay. You know what? Here's my thought processes here. The Dynatel is pretty deep, isn't it, Bobby? Robbie? Yeah, the Dynatel is kind of deep. Let's hold that off. We'll do that some other day as far as that's concerned, and we'll get to that later because that's throwing a lot at you at one time. All right, so today, this afternoon, what we're going to do is, and what I eventually want to get you guys to, I'm going to get back to my paint screen. Bring a notepad and some paper and a pencil or pen because you're going to map out one of the underground feeds for the part of the campus.
No climbing today, right?
No climate today. No, we're doing underground mapping, and you're going to use this map later on to learn how to do cable isolation.
Shorts it is.
Shorts it is. All right. I'm not 100% on this, and I'm pretty sure, guys, you're going to have to wear a mask while you're on campus, even though we're outside. I know we're okay out there at the field, but if you got a mask, bring it today. I've got 4 or 5 on my truck if you need to bring one also. But what we're going to do is out there on, what's the name of that road that goes in? Here's building 300. All right, then we got that road that goes to 501. Here's our field over here. There's a dip hole that's down here that goes into the campus. We're going to go by every piece of equipment, and we're going to log it on notes all the way through the campus, all the way over to Technology Drive. Once you have that on paper, we're going to start the process of learning how to do isolation in and out of these transformers. The objective here is for you to be able to come into a complex such as this and be able to identify, and these are the three things to remember. Identify, isolate, and restore. Okay, so that'll be part of our process today. It won't take very long to walk this out in the map part like that. Once we get done with that, we'll head back over to our underground yard, and we might start even doing the process over there of showing you how to isolate a span and get it on standoff bushings and feed-through bushings. Robbie, I picked up about 6 of each from the service center yesterday.
Okay.
All right, any questions as far as this morning is concerned?
So do you want us to meet in the little parking lot behind 300 or just meet over at the regular spot?
I mean, my feet work okay. We can park over, you know, the parking lot that's right beside the parking lot, the gray area for the golf green?
Yeah, that Crush Rock parking lot.
Yeah, you'll probably see me over there. But not, yeah, that crushed rock one, but the actual asphalt one that's on the other side of it.
Yeah.
Yeah, we'll park right over there, so we'll be able to walk out one direction, come back to our vehicles, and then walk the other direction.
Sounds good.
Okay. Any other questions there? All right, 12:30 at the parking lot. We'll see you guys out there.
Woohoo.